The modular monolith architecture sits as the middle ground between monoliths and microservices, giving you the benefits of both of these architectural styles. Now, the base building block of a modular monolith is a module, and an important rule that you want to enforce is data isolation between your modules. In this video, I'm going to show you how to implement data isolation using EF Core. Here's a visual representation of a modular monolith architecture, and each of these building blocks represents a specific module inside of the modular monolith. What we want to achieve is data isolation between these modules, and I'm first going to explain what options we have on the table. The first level of data isolation inside of a modular monolith is having no isolation. All of your data sits inside of the same database. Everything is inside one schema, inside of the same database, using the same database type, in this example, a relational database. If we take it one level further, we can separate our modules using schemas. So we're using different schemas for each of our modules, but we are still inside of the same database, and we are still using the same database type. Now you can see that we have three modules here: the orders module, the users module, and the finance module, and the tables for these respective modules all live inside of a dedicated schema inside of a larger relational database. If we take this further, we can elevate the logical separation that we get with schemas into physical separation by splitting the modules into separate databases. So now we are using different schemas and different databases to achieve isolation, but we are still using the same database type, in this case, a relational database. So now we have a database for the orders module, a database for the users module, and a database for the finance module. You can probably see where I'm going with this. The next level of data isolation is being able to use a different persistence mechanism for your modules. So now we have different schemas, different databases, and different database types for each of our modules. In this example, I'm using a document databases for my orders because I have a lot of unstructured data. I'm using a graph database for my users module because I will need to inspect the relationships between the objects that I have inside of my database. And for the finance module, for example, we are using a relational database. So now let me show you how we're going to implement logical separation between our modules using EF Core. In this example, I have two modules in my system, the training module and the users module. The modules are organized using the clean architecture, and each module has a dedicated database context. So for the users module, we have the users database context, and in the training module, we have the training database context. So this is already giving us a certain level of separation inside of the code because the entities and the related database sets inside of a database context are organized into distinct modules. Here you can see the entities for the training database context, and here are the entities that we have in the users database context. We're also applying entity configurations from the respective assembly, and the same goes for the training module. Now what I want to do is to define a dedicated schema for each of my modules. Right now, there is no separation at the database level, so I want to at least enforce logical separation using schemas. And how you can do that with EF Core is by calling the hasDefaultSchema method inside of the onModelCreating method. So let's say for the users module, I want to define a users schema. Let's do the same in the training database context. Only here I'm going to define a training schema. Instead of hard coding these values, it might be a good idea to create a class containing a constant inside. So I'm going to define a static class inside of the database folder, and let's call it schema. This class can be internal. I'll make it static, and let's define an internal constant string that I will call users. And then the value of this constant is going to be the name of my schema. Now, if I go back to my database context, I can now replace this by saying schema and then users. This allows me to reference my schema in multiple places in my code, and it also makes it easier for me to refactor this if I ever need to do some refactoring related to schemas. Let's apply the same approach into the training module. So I'm going to copy my class into the database folder. I'm going to adjust this to be in the training namespace, and the schema is going to be called training with the respective value. If I go over to the training database context, let's update this to say schema and then training. So this is a good first step towards achieving logical isolation in the database. Now what we need to do is to create our migrations so that we can actually create these respective tables in the appropriate schemas. So let's go ahead and do that. I'm going to start from my users infrastructure project, and I'm going to create a migration for my users database context. I'm going to say add migration, and then I need to give my migration a name. So let's call this create tables, And then I need to provide a few arguments because I have multiple database contexts inside of my solution. So let's scope this to the user's database context, and I'm also going to configure the output folder to be database/migrations. Let's go ahead and run this and check out what we get from this command. Here is our new migration for the users module, and let's check out what we have inside. I won't spend too much time on this, but I want to highlight that we are enforcing that the schema for this database context is called users, which is what we expected. And then we are creating the respective tables that we have inside. And again, the schema for each table is set to users. We also have the users table inside of the schema with the same name. Then we have the followers table and the respective indexes. Let's go ahead and create the migration for the training database context. So I'm going to switch my target project to be the training infrastructure project. And I'm going to update this to use the training DB context. Everything else remains the same, and let me create the migration. Here's the migration for the training module, and you can see the same pattern where we are defining our training schema and then all of the tables in the respective schemas. Now, if you were paying attention, you might have noticed something, and this is that I have a dedicated Outbox messages table for each of my modules. So if I go back to the migration for the user schema, you can see an Outbox messages table here, and then there is the same table inside of the training schema. So I'm duplicating the same table between my modules because I want to keep my Outbox messages for each module isolated from each other. This also has other implications. For example, how are we going to process the Outbox messages? We're going to tackle this a bit later, but first, let's see if we need to fix anything because of the changes that we just introduced. So remember, we defined the schemas for the training module and for the users module. Schemas also have an impact on the SQL queries that you are going to be sending to your underlying database. If you are only using EF Core to send your queries, then you don't really have to think about this. EF Core is able to properly generate your database queries and also specify the correct schema based on the database context. But if you are writing your SQL queries with something using Dapper, then you will have to define your schemas manually. So let me try to find some query handler. For example, the getUserById query handler. Notice that I'm selecting from the users table here without specifying which schema this should be. So to fix this, I will have to specify my schema directly, and then this query is going to work. Let's check out the other query handlers that I have. So here's the getUserByEmail query handler. I'll do the same thing. If I go look at some other examples, for example, the getFollowerStats query handler, I have the same thing here, except I'm referencing the followers table, but still I need to say that this is inside of the users schema. I also have two more query handlers, the getWorkoutById query handler, which is querying the workouts table and then joining on the exercises. This is now part of my training schema, so I will have to specify this in my raw SQL query that I'm executing using Dapper. And I have one last query, which is the getRecentFollowers query. And here I'm selecting from my followers table, and then I'm joining on the users table to get some related information. So this is something that you will have to pay attention to. If you are writing your queries using Dapper, for example, you will have to specify your schemas manually inside of all of your queries. Otherwise, if you are just using EF Core or the repository pattern over EF Core, then you don't have to worry about this because EF Core will properly reference the schema for you, which is another reason why EF Core is so awesome. One more thing I want to show you when it comes to database migrations is what happens if you create migration scripts for your database context. So let me pick my training database context and call this script migration command. This is going to give me a SQL script that I can execute on my database, and these will be the same data definition commands as if I were running the update database command. So you can see I'm creating a migration history table, and if you take a look at this, you will see that the migration history table isn't inside of the training schema. We are only defining the schema afterwards with this command here, and then I'm creating all of the tables inside of the training schema, which you can see here, which is a bit weird, right? Let's see what will happen if we script the migrations for the user's database context. So I'm going to reuse the same command, only this time with the user's database context. And here's the SQL script for this database context. So here's the user schema, the respective tables inside, and again, the migration history table isn't inside of the schema. And this is something that you will realize only after the fact when you run your migrations, and that is that the migration history table isn't affected by your calls to the hasDefault schema method. If you want to have, and you should have, your migration history tables also as part of the schema, this is what you'll have to change. When you are configuring your EF Core provider, in this case, I'm calling the use MPG SQL method. You can also configure the database context options builder for this particular provider. And here, what I can do is access my MPG SQL options, and then I need to call the migration history table method, and this allows me to specify the table name and the schema for the migration history table. So for the table name, you can access the history repository, which is inside of the EF Core namespace, and this contains a constant with the default table name, so we don't need to change this. But for the schema, I'm going to access my schema static class and then specify my training schema. And then let's apply the same in the users module. So I'll head over to the dependency injection code, and I'm going to update this. And of course, I need to make this reference the users schema. So let's try to script the migration again. I'll use the users database context for the example, and let's see if this changes anything. And now if you take a look, here's the EF Core migration history table, but it's correctly placed inside of the users schema. And the same is going to apply to the migration history table for the training schema. So if you want to achieve complete isolation at the database level, this is something that you will have to do. Now, I mentioned that we were duplicating the Outbox messages table, and what I have to process this table is the process Outbox messages job. This is a recurring job that I'm executing using Hangfire. And if you take a look at the job implementation, you will see that I'm querying the Outbox messages table. And this is unfortunate because we are lacking the schema for which Outbox messages table it is. So how can we solve something like this? Let me close down everything so that it's not confusing you. And this particular job is inside of my infrastructure namespace. So this is the core infrastructure project that my modules are referencing, and then here is the interface for my job and the respective implementation. So you have two options here when it comes to how you should handle this. You can either create some abstraction that's going to allow you to pass in the respective schema, and then you can reference this schema inside of these queries. And this will make sure that you are reading from the correct table. Another thing that you can do that is also common inside of a modular monolith is to duplicate some code. So I'm going to cut out these files and move them into my users module. I'm going to create an Outbox folder in here, and I'm going to place these files inside. I'm going to adjust the namespaces for these two files to be properly scoped to the users module, and then the interface remains the same, but I need to update the implementation. So here I need to specify the correct schema. So I'm going to say users, and then in the updates query, I'm also going to say users. And then what I'm going to do is to duplicate this inside of the training module. Now, another thing that you will see is that I have a builder here because I'm configuring this with dependency injection, but it no longer exists inside of the infrastructure project. So let's get rid of that. And I'm going to add this inside of my dependency injection in the users module. So let's go ahead and define this as a scoped method, and let's do the same in the training module. So I'm going to add the dependency injection code right away, and then I'm going to copy the Outbox folder and move it into my training module. I'm also going to adjust the namespaces to be scoped to the training module, and you can see that the interface is now correct, but I need to update the interface implementation in this module to reference the training schema. So what I'm doing is duplicating some code inside of my specific modules, and the benefit of this is that I will have more control if I want to separate this module into a dedicated process, and it also makes it easier when debugging because you will know which class you are in based on the respective namespace. Another unfortunate downside to the code duplication that I caused here is that I broke my extension method for configuring my background jobs. At first look, it seems like everything is okay here because I have my using statement here, but this is only going to register my background job for the users module, and there won't be a background job for the training module. So I'm going to update the ID of this recurring job. Let's call it the users Outbox processor, and let's configure another one for the training Outbox processor. So I'm actually going to have two background jobs running, And of course, I need to specify the correct interfaces based on the different namespaces so that Hangfire can get the appropriate job implementation from dependency injection. So this is how you can implement logical data isolation between your modules. Now I want to also comment on one more thing. Here I'm writing a raw SQL query and executing it using Dapper. Now because I'm writing raw SQL, what's stopping me to also making a join to the users table if I can just specify the user schema and the respective table? Well, really nothing, because we only have logical isolation, but everything is still inside the same database. And this will break the rule that modules cannot directly query the data from other modules. However, there is an easy way to fix this. You can define specific users in your database and give each user access to a dedicated schema. This also means that you will define a specific connection string for each of these users. So in this example, we would have two users, one that will have access to the user schema, and then another that will have access to the training schema. And then you will reference the respective connection strings inside of each of these modules, and this will make sure that you can't even write a query to reference the other schema because you don't have access to that schema. If you want to learn more about modular monoliths, I recommend that you start from this video where I'm refactoring a clean architecture solution to use modules. Also make sure to like this video, subscribe to the channel, and until next time, stay awesome.